Converting radians to degrees is really similar. We just want to make sure that when we're multiplying by that unit ratio, that we flip it. So instead of having the degrees on the bottom, because we had degrees that we were converting, we want to have the degrees on the top this time, so that our radians are what is going to cross cancel here. So I'm going to be able to cross cancel my pi's. That's going to happen every time because there's always going to be a pi in there for those radians. And then my 3 and 180, I can divide both by 3. So multiplying my numerators and denominators, I'm just going to get 60 degrees. And we should know, once we get into this chapter a little further, we should be able to look at pi over 3 and know exactly that it's in the first quadrant. Hopefully we will know that it's 60 degrees exactly, but a lot of times it just helps to know what quadrant it's in for what we're doing. One thing I want you to notice is that every reference angle that's 30 degrees, so that distance between the x-axis and that terminal side, the angle is 30, so here at 150, 210, and then 330 as well, they all have radians that have a denominator of 6. Okay, so this was another one that had a 30 degree reference angle, 7 pi over 6 has a 30 degree reference angle, 11 pi over 6 has a 30 degree reference angle, or we could say that it has a reference angle of pi over 6. So that's important. Every angle that has a reference angle of 45 degrees or pi over 4 radians is going to have radians that have a denominator of 4. So our 135 degrees, it has its radians have a denominator of 4 and a 45 degree reference angle. Our 225 down here has a denominator of 4 and it has a pi over 4 reference angle or 45 degrees, and then 315, same thing. And then our last one, everything that has a 60 degree reference angle to the x-axis is going to have radians that have a denominator of 3. We see that here with 120, 2 pi over 3. We see that with 240, 4 pi over 3, and then at 300, 5 pi over 3. So a lot of patterns to start noticing as we're going through this. That is going to help you to memorize, to remember the radians, and when we get to trig functions later, that'll help you out there as well to start noticing some patterns. The last thing that I want to talk about is coterminal angles, and the definition of this sounds a little bit more complicated than it is. They're angles that have the same initial and terminal side. So angles that have the same initial and terminal side. Okay, so it sounds more complicated than what it is. All this is talking about is an angle that ends up landing in the exact same spot as another angle, even though it's gone around the circle more than the other one has, more or less. So if you had like a 30 degree reference angle, or 30 degrees, something that would be coterminal with that would be an angle that maybe went around the circle once before it ended at that same spot, the same terminal side. So the first one would be 30 degrees. And then the second one, since it went 360 degrees around, it would be 390. So basically, any angle plus a multiple of 360 is going to be coterminal. So if you had a 45 degree angle and you added 360 to it, those angles would be coterminal. If you had a 60 degree angle and you added 720, so it went around it twice, those would be coterminal. Or if you're dealing with radians, you would have that angle plus 2 pi, because we're going around a circle in radians, a multiple of 2 pi. So if you had a reference angle of pi over 6, and then you added 2 pi to it, then that would be coterminal with it as well. By the way, if you were dealing with something like that, pi over 6, and you were trying to figure out an angle that was coterminal with it, we would need a common denominator for sure. So I would multiply this by 6 over 6. And that would tell me that 13, oh, I wrote 33. Oh no. Pretend that's a 13. They would know that 13 pi over 6 is coterminal with pi over 6. So before I leave you to your own practice, I just want to go through some of these where we're thinking through what quadrant the angle lies in, whether we're talking degrees or radians, and then also its reference angle. This is really important that we can go through this. So we're going to start with degrees, and we've got the 210. With anything like this, where we're trying to decide where it's at, what its reference angle is later on when we're finding sine, cosine, and tangent, things like that, I want to go ahead and draw it. And I'm just thinking through the fact that for degrees, I've traveled 90, 180, but then not quite to that 270. So my 210 is going to be somewhere in here. So that's my 210 degrees. And then whatever x-axis degree I am closest to, I'm going to either subtract from that or take that degree and subtract 210, whatever makes the most sense. So for this one, since I'm past 180, I'm going to take my 210 and subtract 180 from that to see that my reference angle is 30 degrees. So this right here would be 30. All right. All there's to, oh, we didn't say what quadrant. So this is definitely in quadrant 3. Okay. So same thing with 120. I'm going to start by just sketching. This doesn't have to look perfect, but just giving you an idea of for 120 degrees, we're not quite 180, so we're somewhere in that second quadrant. So just deciding where it falls. But then, like I was saying with this, just whatever makes the most sense to subtract from. It is closest to the 180 is going to be the x-axis that we're going to refer to for this reference angle, but it makes more sense to take 180 and subtract 120 than it does the other way around. So our reference angle this time is 60, and that would be talking about this angle right here. Okay. We've got the angle 405. So definitely can have some angles that are greater than 360. So that just means that it's going to go around at 360. And then we have to figure out what's left in it. So I would want to go ahead and take 360 and subtract 405 to see what's left. Or you could even, if it was really big, you could keep subtracting 360 and that would at least tell you where it's going to land. And for this one, when we take that 360 and subtract, or take 405 and subtract 360, we're going to end up with 45. And that is its reference angle right there. It lands in the first quadrant, and then its reference angle is 45. For number 4, we've got a negative angle. That just means that instead of going through the quadrants 1, 2, 3, 4, we're going to go backwards. So I'm going to start in the same place, but I'm going to go this direction instead. And now this is still 180 degrees in this direction, so not quite 280 degrees, and I think I really went too far there. But it is going to be stuck in the third quadrant. And if I take my 180 and subtract 120 from it, I'm going to get a reference angle of 60 degrees. So actually ended up being the same reference angle as number 2, 120 or a negative 120. Just determine it was in a different quadrant than the other one. Yeah. With radians, we're going to be doing the same thing. It just might be a little bit trickier to figure out what quadrant it's in, what reference angle, just because we're not as familiar with radians. But what we want to notice here is that in front of the pi, we've got 3/4, so that's something that is greater than pi halves, but is not quite to pi. So we're somewhere in here. And if I take, just like what I've been talking about, taking that wherever that terminal, just like what we've been doing, whatever that x-axis angle is, we're going to subtract my 3 pi/4 from it. So my angle here is pi, and I'm subtracting 3 pi/4 from it. Which you can probably see at this point it's going to be pi over 4, but I do want to go ahead and get a common denominator, so multiplying it by 4 over 4, and then we can subtract and get pi over 4. So it was in the second quadrant, keep forgetting to do that. And the reference angle is pi over 4. For number 6, again, trying to decide what quadrant it's in. We're looking at the fact that this 7/6 is greater than 1, but it's not quite 1.5, so I'm going to be landing somewhere in here. So, in quadrant 3. And then using the fact that this is pi to say 7 pi over 6 minus pi, and a lot of these you can do in your head, getting a common denominator, and then we get that the reference angle is pi over 6. Remember that pattern that we were looking at, that if it has that denominator of 4, it ends up having the reference angle of pi over 4. If it has the denominator of 6, it ends up having that reference angle of pi over 6, or 30 degrees. So, some things to notice. Our last one, we've got 13 pi over 3. So if I'm trying to figure out where this goes quadrant-wise, 3 goes into 13, 4, and then a little bit. So if I have 4 pi, that means that this went around the circle once for 2 pi, another time for 4 pi, and then I'm still going to have pi over 3 left over. So you could think of this as 4 pi plus pi over 3. That's what would be left over. 4 1/3 pi. So what we're left with is in the first quadrant, and our reference angle is pi over 3. Congratulations! You've made it through your very first video lesson. Now is the time for you to choose one of those 2 ways of practicing. You can choose either Delta Math or using your textbook for practice, but get started on that. If you have any questions, either specific to a problem or something from this lesson that was just not making sense, you are welcome to message me on Google Classroom, or you can email me your question, or you can just set it aside, put it somewhere where you can easily ask it tomorrow during the Zoom chat. So lots of options on getting help if you need it, but good luck.